Hello everyone and welcome to this Python NumPy tutorial for complete beginners that have never used Python before. By the end of this tutorial, you should expect to know how to print and run cells in Python, how to import and install packages in Python, what is NumPy and NumPy Arrays, how to create NumPy Arrays either manually or using the standard ways of creating NumPy Arrays, how to index the data, how to check the data types, how to do array maths either manually or through functions, how to reshape, transpose, and broadcast data using NumPy arrays. Let me just say that this tutorial is geared towards data analysts and data scientists. I'm not going to teach you anything that you're not going to be using in your day-to-day job as a data analyst or data scientist. Right, if you don't have Python already installed, I'm going to have a video in the description where I explain how to set your Python environment up, how to download and install it and launch it, and how to install all the libraries. Additionally, if you want to download this file as it is with just the titles, not the code, so you can follow this tutorial, I'm going to have a link in the description where I'm going to have the file uploaded in my GitHub repositories. And additionally, I'm going to have the final file too with all the calculations that we're going to be going through the video. To start with, what is NumPy? So NumPy is basically a Python package or a Python library, which is the same thing, that stands for numerical Python. So you can see NumPy. It is used for scientific computing by using array objects. So what is an array object? So this picture here helps us understand what is an array. So an array is basically a set of numbers. You can say it's a list of numbers, but saying list in Python means a different thing. So let's say it's a set of numbers. So a one-dimensional array, so all these are arrays, is called a vector. A two-dimensional array is called a matrix, and from then and on, a three-dimensional array is basically a 3D, so three-dimensional array, and an n-dimensional array, so you might have 10 dimensions here, is a 10-dimensional array. Right, the last thing now, NumPy uses all these vector, matrix, and array operations when it applies calculations, which saves you coding time as it takes less code to get to where you want to, and also execution time. They execute faster, they run faster, just because you don't have to go through every single line, let's say, in your table or in your list when you're writing while loops. I know it's a bit difficult to understand this as a beginner, but you're going to understand this later on once you've mastered NumPy and Python in general. Right, just to familiarize yourself now to how to use Python. In Python, when you want to pass a number into an object, all you have to do is just say a equals 10, for example. And then to run this, you can either click on cell and run, or you can click Control and Enter like this, and then this is going to run. So let me just type it in. So this is CTRL plus Enter equals run. By the way, sorry, I haven't explained. If you add a hashtag in front of your code, then it means it's a commentary and it's not actually going to run. So you can see if I remove the hashtag, it changes color. If I add the hashtag, then it's commentary. Right. So if I run this now, Control and Enter, you can see that it's not actually printing anything. To print this now, I have to actually say A and then click Control and Enter. And now we can see that A output equals 10. So if I have B now here equals 11, and then I run the first one, and then I run B here, I can see that B equals 11. However, it's not running A now. So I only have the latest. So in Python, when you're printing, it's only going to print the latest object that you call. So let's say we also have C here equals hello, for example, and then I type in C2 down here, click Enter, Control and, oh, I haven't run the first one. So you can see I get the error that C is not defined. It's because I haven't run the first one. So if I run the first cell and then the second cell, we can see that it prints hello. So if I want to print all of them now in one go, I want to be able to see both A, B, and C, I can add the print in front of them, and then open brackets, A, And then if I run this now, it's going to print me the A, It's going to skip the B because it doesn't have print, and it's going to print the C because it's the latest object. So you can see 10 and hello. So if I add print on B now too, control and enter, we can see that we have 10, 11, and then hello. Right. So to add a new cell now and keep creating new code, I can go here when it says plus. So you can see it adds new cells below. To remove these cells, I can actually click the cut here. So it's removing the cells. Right. When you're creating a new Python script, the first thing you want to do is to import the libraries or packages you're about to use. Some of the most widely used libraries out there is NumPy, which is this tutorial, Pandas, and Matplotlib, which is the three main libraries that all data analysts and data scientists are using on their day-to-day job. To do this now, all we have to do is say import. I'm going to start with OS. So OS stands for operating system, and it provides functions so you can interact with the operating system. And then I'm going to say import NumPy as NP. NP is easier to call it as NP when you're calling NumPy functions. That's why we're saying as NP. So here in OS, I'm just going to copy this commentary here, so we're saving time, so you know what OS is. If you don't have NumPy installed, to install NumPy, all you have to do is to say pip install NumPy in the terminal. And just to show you how, you go to start, you type in Anaconda Navigator here, the prom. And then here in the prom, all you have to say is pip install NumPy. There we go. So it says requirement already satisfied. So because I already have it installed, otherwise it's going to start installing NumPy. Right. The next thing we want to do now is to create an array. So as I said before, a NumPy array is a grid of values. I said values before, a grid is the same, and they all have the same type. So they are all arrays. To create an array now, I can say a equals np.array, then open brackets, open the square brackets, and say 1, 2, 3, and 4, and then click enter. So np is not defined, so this is because we haven't actually run this cell here where we import our package. So if I run this package first and then run this below, this worked. So if I click A just to print it, we can see that this is an array and it starts from 1, 2, 3, and 4. To check the type now, I can just say type A, click enter, and then we can see that it's a NumPy and the array. Right, check the number of elements. To check the number of elements, all I have to do is say a.shape and then run this, and we can see that I have 4 elements. So 1, 2, 3, and 4. Select the index. Right. So when you're indexing arrays now, so if I say a and then into square brackets I put 1, I am not actually going to get the first number. I'm going to get the second number because, let me just run it so you can see. So I get number 2 because in Python, always when you're indexing, it starts from 0. So if you want to get the first number, you actually have to say 0. So just to test it, click enter. So you can see we get 1. Another way of doing it is that you can say if I say minus 1, it's actually going to start from the end and moving forward. So if I run this, we get number 4. So if I say minus 2, it's going to get 3. If I say minus 3, it's going to get number 2. Right. When we try calling something that is out of bounds, so for example, a square brackets 4, it's throwing us an error saying that index 4 is out of bounds. This is because, as I've explained before, the array starts from 0. So number 4 is actually A3. So if I type in here a square brackets 3 is number 4, as we can see here. Now, when you're running scripts from start to finish and you don't want to have any errors like this that is going to be stopping your script, so it's not going to be running the whole code as soon as you find the first error, you can try and write something that says, if this is giving me an error, then try something else. To do this, we can say try, then colon, then click enter. So after every column, you have to click enter in Python, and you will also notice that it pushes the index on the right. So if I continue writing here at the same length as before, then it's still going to throw me an error. It's not going to work. I have to be exactly under the column. So now I can say if a square brackets 4 try a4. However, if this gives me an error, I can say except, and then I can just say again colon and say print a3. So if I run this now, as you can see, it tried the first one, a4, it gave me the error, and then it moved on, except printed a3. So a3 is the fourth number, because remember it starts from 0, so it gave me number 4. Additionally, I can also say except, I can say index error, so I can actually copy this. Except index error, name it as error, and then I can say print the error instead of a3. And as you can see, it gave me the error. So again, index 4 is out of bounds for axis 0 with size 4. So I can actually see the error now, but without having an actual error that is going to stop my script. So this is very helpful to know when you're writing big scripts. Right, the next thing we have to do is changing the elements of the array. Let's say that a manager came in and said, look, the first number is wrong. It should actually be 300. So to change the first number, it's very simple. All you have to do is say A0. Remember, the first number starts from 0 equals 300. And then I run this. I can't visualize it again because I haven't called A. But if I call A again now, we can see that our array has changed from 1, 2, 3, 4 to 300 to 3 and 4. So this is how you can change the elements of the arrays. It's very simple. Right, if I want to create a 2D array now, so remember 2D is anything with 2 dimensions, so it doesn't have to be a matrix because it's not going to be equal number of elements in each dimension. But let's say we want to create a equals np.array, open brackets, then say 1, 2, 3. By the way, I forgot to explain that every time I'm saying a equals, if I do have already something saved in a, which we do have this array saved in a, it's just going to replace it. So I can name this B, C, D, or anything. I can give it an actual name, Yannis equals, but I keep it a just to keep it simple. Right, so I can say a equals np array 1, 2, 3, comma, square brackets 1, 2, 3. And then if I run this, I get the error because if you remember, we need double square brackets at the beginning when we're creating arrays. So if I add the square brackets and call A, we can see that we have a 2-dimensional array now. So it's a 2D with 3 elements in each array. So if I say a.shape, we can see that it's like it's like 2 rows and 3 columns. That's much easier to explain it than using dimensions and elements. If we take it row wise, it's two rows. So again, if I run it so we can see it, it's 1, 2 rows and then 3 elements in each row or 3 columns. And 3 by 3, again, I can just copy this, pasting down here and just keep it as A again, 1, 2, 3, 1, 2, 3, and then add a comma here and say again 1, 2, 3. Run this, we can see it's a 3 by 3 now matrix. And if we check the shape, a.shape, and we run this again, we can see it's 3 by 3. Easier to remember it, 3 columns, 3 rows. Right, if I want to flatten now all these numbers, so what flattened means, let's say the way I have 3 arrays here, I can just make it in one single array. So the array is going to be 1, 2, 3, 1, 2, 3, and 1, 2, 3. So I can say np.hStack and then put the object I want to flatten, so A, and then run this. And then as you can see now, it became 1, 2, 3, 1, 2, 3, 1, 2, 3. However, I haven't actually put this into A. So if I run A again, it's going to be our 3 by 3 matrix. So just remember, it's different to just run the functions of NumPy or any other library, and it's different to actually save this into A. So to actually save this, I need to say A equals, and now A is going to change. It's actually going to be the flattened numbers. Or I can just name this as B. So if I run this now, we can see that A is still the matrix that's being created here, and B has been created from A. So I can just say print. Just remember, if we want to see both now, we have to use print. So print A and then B below, run this. We can see that we have our matrix up here and our flattened array down here. Right. By the way, if you feel that you're getting enough value out of this video, please click that like button and subscribe to my channel. Right, so we've shown how to manually create NumPy arrays by manually specifying the elements in the array. However, NumPy has some set functions that it helps you create arrays much easier. So the first one is the mp.zeros. So let's say we want a 2x2 matrix full of zeros, or maybe we want a 5x5 or a 5x2. So this is just going to put zeros in all your arrays. In all the elements in the array. The n by n with 1 values, you can say mp.ones again and just say 5x5, for example. And as you can see, it created a matrix 5x5 with all ones. Now, if you want to pass a specific number in here, we can actually say mp.full. Full is the function, and then we want a 4x4, let's say, with the number being 10. And then we run this and it created a 4x4 matrix with the number 10 in it. Another way to do it, let's say we want totally different numbers in our array, we can say mp.random.random and then just say 5x5. And then, we need double square brackets. Then we run this. As you can see, it created a 5x5 matrix now with random numbers. These numbers are between 0 to 1. So if we want to make them 0 to 100 or 0 to 1000, we can just say here times 100. And now it is a 5x5 with actual numbers, or times 1000. So now our numbers range from 0 to 1000 in a 5x5 matrix. We can just save it in A and call it in A. Let's see if it looks better. No, it still looks like this. Right, so this is how you can create quickly arrays using random numbers or zeros or ones using some NumPy existing functions. I've never actually used this in real life as a data analyst or data scientist, but I assume sometimes you do want to create some 0 or 1 values, because 0 and 1 is what you're trying to predict most of the times. And then the random numbers are actually very useful. Right, another way of creating NumPy arrays is from lists. So you can take the list and pass it into a NumPy array. To do this, assuming I have a list here of 1, 2, 3, and 4. And then if I call a list and run it, I can see that it's not actually a NumPy array. I don't get this array, it's actually a list. To do this now, I can just simply say list is going to give us an error just because there is no shape in the list. So if I do a.list.shape here, as I have on the commentary, I get an error because there is no shape in the list. Now to pass this list into a NumPy array, I'm just going to comment this out. I'm going to say mp.array and then say copy the a list in here and then run this. You can see that it took these 1, 2, 3, 4 numbers and it passed it into an array. So I can actually give it a name. So a equals this one, and then I can say a.shape to check the shape. So as you can see now, we don't have an error. We have the shape, which is 4 elements in 0 dimensions, 1 dimension basically, which is a vector. I can also specify the type now. So as you can see, if I run A again, the type is integer, but let's say I want it to be float. What I can do is I can say A equals NP array as we have up here, and then say comma dtype, so data type equals float. And then if I call A again, you can see that it added the dot now, which means it's a float. Right, the last way of creating NumPy arrays from existing NumPy functions that I'm going to show is by appending an existing array. So let's initiate an empty array. So saying a equals np.array, and then I'm just going to keep it as an empty array. Sorry, not array. And then print a. So as you can see now, I do have an array, but it's empty, it has nothing in it, with the data type being float64. Now I want to take this empty array and fill it with numbers from 0 to 100. To do this now, I have to say for I in range 100, then column, then again space. Remember, after every column we need space. I can say a now equals, so I'm going to append a. I'm going to say mp.append. I want to append a to be I. So this I now is going to loop 100 times. So it's going to start from 0, then 1, 2, 3, 4, 5, all the way to 100. And the next line, what it says is I want you to go to a, so the existing array, and I want you to append a, so the empty one, with I. And I is going to be having numbers from 0 to 100. But if I print now a here, and run this, we can see that we have an array now from 0 to 99. So remember, it starts from 0, that's why it's 99, but it's actually 100 numbers. Right, so this is it for this video. I'm going to finish the rest of the tutorial in the next video, as I want to keep these videos short. If you feel like you've gained enough value out of this video, please click that like button and subscribe to my channel. Additionally, you can enable notifications so you know when I'm going to upload the next video, which is going to be in 3 days' time. Also, if you have any questions again, or if you feel I haven't explained something very well, please let me know in the comments below so I can answer it. Thank you very much for watching.